Now, the actual, so we have to really thank the speakers who are coming from US as well as I didn't ask Ranga, but I'll ask in a few minutes. Look at Chris joining from San Francisco. Simon, I understand you are also from San Francisco, or I'm not sure where are you from. So San Francisco. So Saturday morning, the speakers are coming and supporting the community. So let's give a lot of respect and take their valuable time, ask good questions, right? And also provide a product feedback, right? So you say, this feature is missing, so that will be really great help for the product managers here, right? And I'm sure you know Chris Bernasali. I'm sure some of you already met during Sangam conference, or we had a couple of webinars. But if you don't know Chris, I'll quickly introduce. Chris is a senior principal product manager at the Oracle HQ, Redwood City, responsible for database cloud services. Chris has been with Oracle for 10 plus years of in various roles, sales, developer advocacy, and product development. Prior to that, he spent 8 years managing database engineering teams for US financial institutes. Chris also a hands-on hacker and avid public speaker. He's has presented technical sessions as well as Oracle Cloud Strategy at events worldwide. So I know Chris personally. I think you can ask any questions. I'm sure you'll get answer. So please keep all your questions ready. The next speaker is Simon La. Simon, first time I think we are seeing an AIOG. So warm welcome to AIOG community. He's also a product manager for Oracle Autonomous Database, a dedicated Exadata infrastructure and cloud at customer. Previously, he was a product manager for Oracle Cloud Infrastructure, Revelo Services, and Oracle Timestamp in-memory database. So I think most of you know about in-memory databases. So welcome, Simon. And we have speaker from Speaker Ranganath Srirangapatna Ramachandra. He's also product manager for Oracle Autonomous Database, dedicated on public cloud and cloud at customer. Previously, he was a product manager for Oracle Database Cloud Services. So we have 3 experts here. So let's start. Let's get started, and I'll also inform other channels, so that they can also join as quickly as possible. And by the way, thanks to you guys, right? So it's a night for India, and let's learn something today. Thanks a lot, Chris. Over to you.
Thank you, Sai. Thank you, everybody at AIOUG. And I know Sai thanked us, but really, I want to thank all the participants. It's Saturday night in India, and I love the enthusiasm that you chose us. You chose to come to our session and listen to us. So very grateful to you. I do miss not meeting everybody. I know that every year we have this amazing event, but hopefully next year. But we do have an exciting lineup of content. And the way this session is designed is to help you learn more about autonomous from a technical standpoint, also with a focus on getting your certification. So if that is something you desire, we are hoping that we'll be able to deliver rich content that helps you get there. Many thanks to both of my colleagues, Simon and Ranga, for participating in this talk with me. So I'm going to share my screen now. And so you can give me a quick confirmation that you can see my deck fine.
Perfect. Yeah.
Awesome. So today's session is called Autonomous Database Masterclass. This is a service, by the way, that is now certified at many levels. And this information is generally missed out, but companies that run financial information or have user data, PCI, DSS, HIPAA, ISO, all of these certifications are in place for the installation on public cloud. For the deployment in public cloud, we also achieved FedRAMP. So now Autonomous Database is available in Gov data centers in the US. So the agenda is split between myself, Simon, and Ranga. And so I will open by explaining what the Autonomous Database is, what are the deployment options, talk about some of the key features and things you should know and understand even from a perspective of the three deployment types, I know many of you might already know we offer that on shared, dedicated, and cloud customer. But for those who are new, I will explain what the differences are, and then the bells and whistles associated with with dedicated deployments. I also wanted to do a very critical live demo. Well, actually, it's a recorded demo for simplicity for the time, but to show you how autoscaling works and how maintenance actually happens via rolling upgrades. And then I would end it with an introduction to the cloud customer and public cloud network architecture, which leads into Ranga's presentation, where he'll go into the details of how each of these services are deployed, what needs to be considered for that, how these databases are monitored, and the security and HA options available. And then in the end, Simon would talk in more detail about the MAA side, the data guard side. He will also do a demo on automatic indexing. That's also a very interesting demo. And then, of course, in the end, we would talk about different options that you have available for migration. So just the basics. And again, most likely it's a repetition because I know that many of you are very, very familiar with Autonomous. But overall, we have to remember the Autonomous database is the same Oracle database that you're used to on premises, which is now offered in the simplicity of a cloud service. The idea is that how do you take an enterprise product, right, like Oracle's database? It's been there for 30 plus years. And there are so many bells and whistles, so many features have been developed over the years. How do you present that and make it available to users in a very simple fashion so that deployment is easy, right? And you don't need, to be highly skilled to deploy an enterprise grade deployment with maybe rack or data guard with security options of encryption, et cetera. How do you keep it simple? So the simplicity of the provisioning through a web UI and through APIs for automation is a core aspect of the service. We also took it further to make sure that the day-to-day functions that are kind of a burden to the customer, right, are automated through either the automation that we have built with the help of personnel who can monitor and watch and react to any events. And so things like backup, patching, high availability, encryption, all of these which you expect to be there are actually there in Autonomous. So you don't deploy any of that. I'm going to stop my video here. Okay. And then we'll focus, some of the key aspects of the service itself, as in how does the service scale automatically? Sizing an Oracle database, or any database for that matter, is always a very critical task for DBAs. Requires some expertise and is never perfect. It's you never get it right. Either you are oversizing or you end up undersizing. And so what is the right solution so that the database can size in response to the workload, right? That's an amazing key feature that's been, that's available in Autonomous. Its ability to scale in real time, automatically in response to the workload. And we have a demonstration of that, so you'll enjoy watching that. In terms of deployment itself, we made sure that it runs in one of the about 36 public cloud regions that Oracle now has, which, by the way, is more than AWS. So we have more regions than AWS already and expanding. Or if you decide to run it in a data center close to you, or your own data center, a partner's data center, you can do that. So the Autonomous database is all available as a clouded customer in your data center or in one of the public cloud regions. Now, in terms of the deployment choices, I just mentioned that, but there's actually 3 ways you can deploy an Autonomous database. We started off with the shared environment, where on a single infrastructure, multiple customers can be hosted, right? So on an Exadata class infrastructure, container databases are deployed, and then each database is a pluggable database in that container database. This model allows us to consolidate a large number of databases. It allows us to keep the implementation really simple. And it's a great choice when sharing the infrastructure with other customers is not an issue. And there are many such use cases for that. We have customers running all the way from dev test to production instances on shared. And the key there is the simplicity, that there is no infrastructure to deploy or manage. There is no container database to deploy or manage. There's only the autonomous database that an end user deploys through a few clicks, and they can get going with it. Now, then you shift to enterprise customers that are looking to enhance their entire database estate. And so, when you have a large estate of Oracle databases yourself, and you decide that you want to put it on your own infrastructure, and you want to have a certain degree of control over it in terms of when it gets patched, for example, then dedicated is the offering that we have for those type of deployments. We have customers that have taken entire database estates on premises and are migrating them to dedicated. And this whole process of digital modernization or database modernization, where customers have decided that they're going to focus their resources on building great applications, maintaining large estates of databases, rather than the mundane tasks of having to monitor backups and work out issues and those things. So that shift and that change to modernize the database is what attracts customers. And that can happen for even small customers. It doesn't have to be, because you get a fraction of the Exadata of the order of, say, 2 nodes, right? Which is a smaller shape, which can still host a large number of databases. So all the way from medium enterprises to large scale, institutions are moving to dedicated to modernize the database infrastructure. And again, for the customers who decide that they want all of that hosted in their own data center, rather than take it to a cloud region for a variety of reasons, data sovereignty, the affinity that it needs to the application, the dependency on the rest of the ecosystem, for a variety of reasons, if they decide that Cloud@ Customer is the right choice, then we bring the cloud, the cloud basically to the customer's data center. So these are the deployment options. Now, given that there's quite a few bells and whistles in dedicated and in a public cloud region or Cloud@ Customer, and there's a lot that you have to learn from a masterclass perspective for CDB administration, virtual machine deployment, right? We're going to focus. You'll see that we are inclined a little bit towards dedicated. Now, a good way to understand this is that in shared, there is no VM cluster to deploy. There is no container database to deploy. There is no Exadata infrastructure to deploy, right? So, of course, when we talk about those things, we are talking about dedicated and Cloud@ Customer. When we just talk about the Oracle database, the ADB, the Autonomous Database, then that applies to all 3 platforms, right? So all of us would try and make sure that when we speak about some topic, we will be very clear whether it applies to dedicated or shared. But I think as a general rule of thumb, it'll be very clear that when we talk about these components, they are available only in dedicated from a customer standpoint, and therefore that itself should be very clear. Now, very quickly, I will talk about the key aspects of the service that you should know, even from your certification exam perspective. What is it that Autonomous offers, right? So number 1, as I said, provisioning. The ability to provision from a very simple, give me an Autonomous database that has 2 OCPUs, 1 OCPU, and an amount of storage. Just very simple provisioning. I want a database in 2 minutes that I can develop on, right? That ability to an end user, whether that's a developer, line of business user, DBA, whoever that is, to a more complex deployment consisting of Exadata clusters deployed across regions and replicating in real time over data guard. And you can imagine that sort of a deployment on premises can take to the order of weeks, I would say, by the time you get everything up and running for a variety of reasons. And to simplify that and to say that, within 30 to 60 minutes, you have that complex setup ready from scratch, right? With the ease of, being able to just click through some screens, provide some information in a UI, or call an API if you're doing it automatically, or orchestrate that through a Terraform orchestration along with other components in OCI. That simplicity of provision is what we target, right? So all the way from simple to complex, mission critical deployments, we have created simplicity so that it takes very little skill to provision those deployments. The focus has also been on security. Of course, as 10 of the 10 top financial institutions in the world, 10 of the 10 top telecom in the world, you name it, run their most important applications, right, on an Oracle database. If you go to an ATM somewhere, there's a good chance the backend database is an Oracle database. And of course, you expect that it'll be highly secure. And you can imagine over years, that has been our focus. And we continue to bring that to the Autonomous database. There's a lot of features. Ranga is going to talk about some of that, but in terms of how we encrypt the data automatically using the highest standard TLS 1.2 encryption, encrypt the connection between the client and the database itself. So you use a TLS 1.2 certificate-based authentication and a client-side wallet to connect with your database. And also the way we manage the keys so that the keys can either be, the keys can be stored in an external device and, a compliant HSM device in the public cloud, or if you're using cloud at customer, then in a key vault. So key protection, certificate-based, trust-based authentication, encryption of data on-prem, and overall, generally, of course, not to mention the security of the assets itself, security of your data, implementation of tools so that data is only accessible to authorized users, right? So there are other tools, and then we'll get into the details of that later on. From a management perspective, as I said, automation of all of the maintenance. So taking away the mundane tasks of, regularly backing up your data, keeping track of that. Patching is a big aspect, both from a security standpoint as well as management standpoint. The ability to patch in time, right, when vulnerabilities are detected in a timely fashion, being able to patch to the extent possible without asking for downtime from your customers, right, your lines of businesses. Those are big ticket items, right? And those are the reasons why these things stay behind, is because you're not able to get the downtime, and business will not let you take it down, or the amount of time needed is high. All of that automation is what makes Autonomous a very attractive feature for customers. Is the ability to do all that through automation, not be responsible for it as a customer, but have the control to make choices in terms of when you would want that to happen. But let the automation take care of it. And, I would say in most instances, keep your applications up and running, so you're not going to your business and asking for downtime when such maintenance and management operations happen. From an HA perspective, when I say protection, it's all about, protection of your business, right? And so the availability, and you have different options of how you want to deploy your database infrastructure, your database, and the degree of protection that you desire. Scalability, I've already talked a little bit about that, and we'll see it in a demo later on. And we think it's a very important feature, and also a great differentiator between how we look at scalability, given that we have provided mission critical databases to customers for decades. And so we understand how scalability needs to work, right? It's not, we'll come to that. The ability to scale in real time is super important when it comes to databases, because customers don't have the luxury of taking downtime. And then finally, bringing the whole machine learning aspect to it and being able to detect issues before they occur and building automation inside of the database itself that optimizes your workload. Now, I will talk a little bit about dedicated, as I said, because here we identify a role for the customer. So the way the service is envisioned is that we expect customers to manage large fleets of autonomous databases. And there's a certain degree of management and control responsibility that the customer has. As I said, picking the right option, right? Does this need to be replicated across regions in the same region? Is this a mission critical applications? Those choices of provisioning can be made for the fleet by what we call as the fleet administrators. And I would say for the most part, we have seen that fleet administrators are the IT DBAs, right? In some cases, we have seen line of businesses manage that as well, but for the most part, corporate IT and DBAs who manage databases on premises do take up the charter of being fleet administrators. And then you have the developers or the users, which are the end users. They know how to use an Oracle database, connect an application to it, and use it. And so these are the two different roles from a customer standpoint that we envision. It solves a lot of problems. It solves a problem that IT needs to govern, regardless of who the cloud provider is, because every corporation's security guidelines or management guidelines are different, and somebody has to keep an eye in terms of that these are being adhered to. And so the fleet administrators, without actually having to do a lot of database administration, right? So without having to worry about backups or patching or deployment of rack or data guard and understanding the internal workings of these, they are able to now administer large fleets of these databases, which again, by the way, as you know, is ever expanding. Every DBA is multiplying the number of databases they administer anyway. So this is a great way to make sure that you can have control, you can have a consistent security architecture across your databases, and you don't have to prioritize based on availability of time and resources anymore. And then at the same time, the end users get the agility that they need. So basically, it's kind of a win-win both for lines of businesses, developers, engineering teams who need the agility, as well as mainstream IT that needs to maintain control, but at the same time respond fast to the demands of these developers and DBAs. Key aspects of autonomous maintenance. And so we get into a little bit of the details of that. Number one, the picture on the right shows you what Oracle is responsible for, right? So Oracle is responsible for the Oracle home, the database, RDBMS, all the way down to every hardware component that it runs on. So the entire stack, the software that runs on it, the hardware components, the pieces, the frame itself, everything is Oracle's responsibility. The customer is responsible for the data and the schema, and that is something that is hands-off to Oracle. And controls are put in place so that customers' data is clearly separated. The data inside the PDBs is clearly separated from the rest of the software and hardware components that it runs on. Okay, so Oracle is responsible for the availability of the database. If the database goes down, or a node goes down, or an instance goes down, we detect that before anything happens. If a hardware component fails in the Exadata, we detect that. All of that, again, applies to shared or dedicated, either way. Okay. When we patch, the objective is to patch in a rolling fashion across nodes so that at any point capacity is available to the application isn't down. You may lose some capacity depending upon the type of deployment. Again, if you have dedicated, as I said, you have a choice of infrastructure. So if you have chosen a 2-node deployment, and if you patch and if one node is down, then yes, you have 50% capacity, but that's a sizing that you would do depending on the type of applications you would want to deploy. But overall, patching is done in a rolling fashion. Patching is done on a quarterly basis. So we have quarterly release updates, RUs and RURs. And there's a scheduler, which by default picks a time every quarter to patch your databases. So the patching can happen for the infrastructure separately, and then each container database is patched separately. Once again, this control is available in dedicated, because again, that infrastructure and CDBs belong to you only. In shared, patching is scheduled, at a predetermined time, and as a customer, you may not have control over changing that, right? Because again, remember, if there's more than one customer in one container database, so this control that I'm specifying applies to dedicated deployments in public cloud and cloud at customer. And so customer can, in these deployments, select, choose a schedule. And so you can go to the UI and can specify when you would like the patching to occur in that quarter. So you can actually preset the schedule for the entire year, right, in advance. And then the scheduler will automatically pick up at your scheduled time, and it will apply the patch. In the event that you decide you do not want to patch in a particular quarter for that time, you have the option of changing that, even up to about 30 minutes ahead of the actual patching time. So you're able to go in and make a change, open an SR if you need to, if you have any other concerns, and then people get involved if they need to address any specific concerns. Scaling, again, very important, as I said. Sizing is a key aspect of building database infrastructures, as you know. And typically the way we would size for peaks, right? So let's say you have a quarter end reporting that happens in a data warehouse. And that time, everybody in the business is hammering the database with queries, and you're going to use like 5x of the OCPUs that you generally have. You are going to size for those 5x, right? Because you want to support that. Problem with that is that all that headroom is kind of wasted resources for the rest of the time. And so that becomes an issue. And it's a lot of, I would say, wasted resources, wasted hardware, wasted licensing cost, all of that. We solve that problem in Autonomous by providing auto-scaling. And in auto-scaling, what you would do is you would pick a baseline CPUs, which is generally sized to your average usage, right? So you can see this red line in this chart is your baseline CPU. So let's say you pick 3 OCPUs for a database deployment, a very simple, database. When the system demands, when the workload goes up, this can automatically scale up to 3x. So from 3, you go to 9, right? So up to 9 OCPUs, it will scale up to address those peaks or those demands, and then it will scale back down back to 3. So on an ongoing basis, you will be, in a way, billed for 3 OCPUs. And then at times when it needs up to 3x, or it could be 2x or 1.5x, it will get billed accordingly. So huge difference in overall ongoing costs. If you look at this over a period of 3, 6, 12 months, there's a marginal difference in having sized it at 9 OCPUs continuously versus sizing it at 3 OCPUs and scaling up and down. So again, for applications that are kind of fluctuating in the usage of the CPUs, highly volatile applications, whether it's OLTP, even if like a retail application that has seasonal demand, for example, all these are great use cases to use auto scaling and leverage this feature to bring down your TCO. Okay, so I thought this would be a good time to jump into a demo of how auto scaling works, and it actually shows a few things besides just scaling. And so we'll look at how scaling works, what happens in a maintenance operation. So you'll get firsthand idea of when a maintenance operation is kicked off, how does the rollover of connections happen? So in this demo, let's see, first of all, is it playing? Okay, so you'll also get a view of how provisioning works and how OCI looks like. So I logged into my OCI console, and I'm going to go to autonomous transaction processing. So the two ways to get in is through autonomous data warehouse or autonomous transaction processing. And I'm looking at one of my database deployments called SBATP3. I'm running a swing bench application on it, right? You can see the information shows that it has about 3 OCPUs available. Now I go to my compute instance, right? And I start an application there called swing bench. And I'll connect that application to this database. And the goal is to see how that application works when I scale manually in the backend or use auto scaling, either of the two ways. So this is kind of a Java application, very simple Java application that runs a mixed workload, right? You know, reads, writes, inserts. And so I provide a username, password. I provide my connection wallet. I provide a connection string. And this connection string actually comes from the console itself. So it's very easy. I go back to the console. In the DB connection session, you can see that my TNS entries are there. So I simply have to copy this from there and drop it here. And I test my connection. That's all it takes even to connect to a database. So you have all the information you need in the console itself. And you know, you can see that it's a mixed workload. So once I am satisfied that everything is in order, I fire my application. And you know, after a few minutes, you'll see I'm building on my connection. So as you can see, I've decided to have about 100 parallel sessions here, right? So 100 users are connecting. And by the way, I'm using connection pooling in this one. So connection pooling is an important aspect for leveraging the, you know, the failover capabilities. After a while, you see that I've built up my workload where I am, you know, running some 700-800 transactions per second. Right here now, my OCPU count is 3. And let's say I decide that I need to scale up. And I'm going to pause here for a little bit, just so that you can see it. It moves fast. Here, I'm showing you manual scaling, right? So the application is connected and running. I'm going to scale up to 6 OCPUs. Now, I could do that. This is called manual scaling, where I'm changing my base from 3 to 6. If I just check this off, right, as you can see, this auto scaling, if I check this off, then I can automatically scale from 3 to 9 and back to 3 in response to that demand. So if more users connect, it'll bump up the number of, you know, cores available and then bring them down again, right? So that's that. So as simple as that. As you can see, that this is all there is to both manual scaling and turning on auto scaling. So I do that, and I have just issued a manual scale up operation. And while scaling is in progress, my database is still up and available. Right? So no change. I'm still processing about 800 plus DML, no change, no blip. I wish I could fast forward this a little bit to save time so that we have enough time for the rest of the content. Okay, so that is that. And there was also, so I'm going to simulate now what happens when there's a maintenance operation. How do I handle that? So what we're going to do here is we're going to restart the CDB, right? So when we restart the container database, it's a rolling restart, and which is similar to a patching operation, right? Which is a rolling operation. When I restart a CDB, it is going to first, you know, move connections from node A to node B, restart that node, and then do that on the other nodes. So, you know, here I'm showing you that in a 2-node setup, I have some 100 connection because we chose 100 users, and they are connected to instance A, right, in the 2 nodes. And I restart the CDB, and I come back here to look at how my connections are performing. So I'm using plain SQL to view the $GV session view, right? And I'm grouping all my connections. So you can see that about 100 connections on node 1, no connections on node 2. And after some time, you can see the connections start failing over, right? Because it's realized that there's a restart operation. It'll move connections over to node number 2 in about 5 to 10 minutes, depending upon as a transaction completes, a new connection is opened up on the node that is going to survive. After a while, I see that I only have instance 2 available now, right? So my application is running. Node 1 is already down, so that you cannot see it anymore. When I go and check the application out, my database still shows as restarting. If I go and check the application out, it's still performing, no issues at all. Again, of course, now I'm at 50% capacity, right? So depending upon, if I sized it right, it could have been running all 800, 800 transactions a second, or I could have, lost, some throughput there. But my application is still up and running. So that's a sizing thing, but it's available. And here you go. So I'm restarting, and I'm going to check again what happens. You can see that the node has come back up, and now it's balancing the connections once again. And after some time, you see node 2 has gone down, and it's going to go ahead and do that. So this is the way the patching operation works, is that this is the behavior you would expect to see of connections being, failed over to the surviving node, and in this particular fashion, the application stays available. Now, this is achieved because there's a lot of rolling operations that happen. So you can see that, we use rack rolling. The grid infrastructure updates are also 0 downtime. Each of the patches are built so that they are rolling patches. And so far, within a specific version, we have delivered all patches as rolling patches. It's very rare that a patch would require a downtime. That's a possibility, but that's far and few in between. There's also, as you can see, we use transparent application continuity that offers more than just the failover. This failover feature is a rack feature, no doubt, but TAC gives you more than that. TAC uses transaction guard that allows you to take an in-flight transaction, right, to continue on the surviving node. So if, for example, if in a retail application, a shopping cart is being checked out while the database, or that node goes down, then that transaction itself, that session is not killed. That session can continue on the surviving node. So it's a very fine feature, and it's configured and ready and available in Autonomous. All you have to do is, there are certain requirements on the application side to use connection pooling to mark the transaction boundaries clearly, so that the backend knows what a complete transaction is, and then use the right set of JDBC drivers, Oracle JDBC drivers. So very few and simple requirements on the application side to leverage TAC. Now, in the next 5 to 7 minutes, I wanted to walk you through the network architecture and how dedicated differs. So what I'm going to talk about now applies to Autonomous Dedicated. And this would be a good segue for Ranga to then come in and give you a more detailed overview of the provisioning of the VM clusters and the container databases and the security aspects. So we can look at a reference network architecture here. And this is, again, applies to dedicated only. The first slide, this one, is about deploying an autonomous database with the Exadata infrastructure in a public cloud region. And how would you go about it? So from a network standpoint, you see that you get the full support of the OCI, software-defined network. You are responsible for creating the VCN, so you are in control of the network itself. Now, as you can see in this, I've created a VCN that spans 3 availability domains, right? AD1, AD2, AD3. I create subnets which isolate my application servers, my VPN servers, my load balancers, the Exadata infrastructure itself. And so as you can see, I have in this particular VCN that I call OCI VCN that spans 81, 2, and 3, I've created a separate subnet called the Exadata subnet, right, for my Exadata. And I deploy my Exadata infrastructure in that subnet. So all of this is automated. As you go to the UI and you say, okay, I want an Exadata to be deployed. And so you would deploy it using software. The hardware is already there in the data center. You decide how the networks are laid out and how the software representation of a physical Exadata infrastructure, which we call as it's an OCI resource, is deployed, right? So you deploy the Exadata system, you deploy and you define the security rules that identify how this Exadata system will be accessed. You decide which ports are open, whether you want to connect on 2484, 1521, right? Which specific IP addresses or application servers can connect to it. All these are defined in the security list that you create. You create the routing to specify whether the Exadata system is accessible from this VCN, from other VCNs, from the public network. All of that routing is something that you control and you decide. So there's an amount of network control, well, amount as in like full, complete network control that is available to customers. It also means you are responsible for completely isolating this from a network standpoint to your likes, to whatever your corporate demands are, right? And then as you can see, I've deployed my application servers in a separate VCN and I'm establishing connection. Since this is deployed in a public cloud region, and if your application is on premises, or if you need to connect to it, you would connect to that OCI region either using IPsec VPN or using Fast Connect. So Fast Connect is an OCI provided service that provides a high bandwidth connection between your data centers, right, your corporate data centers and the OCI regions. And then there are other advantages also by providing connectivity to Azure regions. So if you are an Azure customer, then there's a collaboration between Oracle and Azure where applications can run in one data center, in one cloud. So you kind of a multi-cloud strategy. So there's physical support for that in the form of user management, in the form of high bandwidth, low latency connections between the two providers. And then finally, a little bit about the autonomous dedicated on-cloud customer network architecture. So this is the same Exadata infrastructure, but now this is deployed in your data center. So how does that work? When you ask for an autonomous dedicated on-cloud customer, the physical server is shipped to your data center of choice, right? On this server are what we call as local control plane servers, right? And these control plane servers is where that connectivity between that system and your tenancy happens. So again, this is still for you, the experience is going to be very similar to public cloud. You'll go to the OCI console, you'll see that as a Exadata infrastructure there, and you will work with it just like it was a cloud database, right? Exact same experience, except the hardware is sitting in your data center. And this is possible because this host will talk to the cloud tenancy via an outbound VPN tunnel, right? So there's no incoming connections to the server for security reasons. The connectivity is outbound. So it makes an outbound connection to the Oracle admin tenancy. As a customer, again, remember at the top, as you can see, you would continue to use the UI or REST API calls to OCI to manage the lifecycle operation of various resources, Exadata infrastructure, container databases, deploy autonomous databases, etc. Any administrative functions like patching operations, all of these that Oracle is responsible for happen through this secure SSH tunnel, this outbound tunnel that goes from the local control plane service to the admin VCN. Over this tunnel is where all the calls to the backend, to the database engine, to perform these life cycle operations happen. So as you can see, all of the virtual machine life cycles, infrastructure, any troubleshooting for incidents. If you open an SR, and if somebody has to connect to the database to see what's going on, it would happen over the secure tunnel. There's a whole, protection, auditing infrastructure in place in the form of what we call as operator access control that ensures that all operator actions are audited, and the customer has complete visibility into what is going on and what is being accessed on their servers. So that's the difference. Is the things to remember is that the outbound connectivity over which all administrative and API calls happen, and then the fact that the infrastructure sits on premises and the customer end user's experience is exactly the same from a database lifecycle and provisioning standpoint. So with that, I would like to transition over to Ranga, who's going to take this further and talk to you about the autonomous dedicated resource model, provisioning aspect of it, and various other things. So I'll stop share and pass control to Ranga.
Hey, thank you, Chris. All right, let me share my screen. Screen 2. Yeah, I hope you guys can see my screen now. Confirmation?
Yes.
All right, excellent. So thank you. So yeah, Chris already mentioned high-level agenda that I'll be covering now. So we'll start with the resource model, then look at all the provisioning of all the resources related to Autonomous Database Dedicated. And we'll also look at monitoring Autonomous Database. How do you manage maintenance, scheduling? How do you manage encryption? And eventually we'll also look at high availability for Autonomous Database Dedicated. Right, so let's jump right in. All right, here we go. So yeah, so Chris already mentioned a lot about all the resources, not a lot, maybe quite a bit about all the resources involved in the dedicated Autonomous Database Dedicated resource model. So in this slide, we'll cover the resource model for Autonomous Database on public cloud and also on Exadata Cloud at Customer. So just even before we start about the current resource model, I would like to highlight that until recently, Autonomous Database Dedicated on public cloud had a slightly different resource model, where the base layer was something called as Autonomous Exadata Infrastructure, which obviously is your Exadata infrastructure. This was the first resource you even had to create before you could create your autonomous databases. And then on top of the Exadata infrastructure, autonomous Exadata infrastructure, you would create your container databases. This is again autonomous container databases, and inside those you would create your autonomous database. But when we launched Autonomous Database on Exadata Cloud at Customer, we launched with the resource model that is displayed on the left side, where the first layer is the Exadata infrastructure, which is a common layer between the autonomous database on XSCC, Exadata Cloud at Customer, and also the Cloud at Customer offering itself. And on top of your Exadata infrastructure, you create your autonomous VM clusters, which happens to be your OS and your grid infrastructure layer. And inside these, you create your container databases, and the databases are basically pluggable databases inside your container databases. So the reason why we even migrated from this model, the old model where there was only one AEI and there were ACDs on it, to the one on the left where we have autonomous VM cluster model, is because this has a lot of advantages once we start supporting multiple VM clusters on the same Exadata infrastructure. Our long-term goal is for you to allow for, creating autonomous as well as non-autonomous VM clusters on the same Exadata infrastructure. And that is why we have actually consolidated and moved to this resource model. So when we support multiple VM clusters, the advantages are as like this will allow you to more effectively manage your, efficiently manage your Exadata resources. You could also have different license models for your autonomous databases on the same Exadata infrastructure. As of now, you can have only one. So you could have separate maintenance scheduling for your VM clusters as well as container databases. And lastly, you'll have better network isolation for your database workloads when you have multiple VM clusters. All right, let me go to the next section. All right, so here on forward, we'll look at creating all the resources that are part of the autonomous database dedicated. So to start off, this is the base layer. As I had said, this is your Exadata infrastructure that you have to start off by creating. And we'll be focusing mainly on the public cloud and also talk about the differences that we have in the Exadata cloud at customer space as well. So Chris mentioned it time and again that the whole process of provisioning resources in dedicated is extremely simple. And I will be showing that again and talking more about it as well. As you can see, creating the Exadata infrastructure is basically one simple screen where all you need to input are like very minimal information. So you start off by selecting your compartment, you enter a friendly name that you want, a display name that is visible on the console, and then you select the availability domain in which you want this to be deployed. In the screen, we are seeing a region that has only one availability domain. We have 4 regions that have 3 availability domains as well. And we could add more availability domains to newer regions based on the demand. So the important thing to look here in the screen is the ability to configure your compute and storage configuration. So X8, M, and above are something called as flexible shapes, where you start off with a base configuration of two database servers and 3 storage servers. But you can grow to any combination of these numbers as you grow, as your data grows. So you could, as your data grows, you could scale your database servers, which is nothing but your node count. I saw someone ask that question in the chat earlier. What is the node count for the autonomous database? This is what determines it. You could scale your database servers, and that increases your node count. And at the same time, if you need more space for your data, you could scale your storage servers, and that adds to your database space. All right. So yeah, in this screen, we also provide you option to set your custom maintenance schedule. So we will talk more about this in the next section. Other than that, when you create your Exadata infrastructure, we also ask you to provide your contact email, like the operations folks within your team, so that whenever there is any operation or any issues or there is general announcement that we need to make, we will send the notifications to the contacts that you provide here. Right, let me move to the next screen. All right, so this is the maintenance scheduling. So this is the preference that you provide to us. By default, it will be in no preference. If you don't have any preference, we'll schedule your maintenance based on our internal logic. And if you have a very specific schedule, like for example, you need your maintenance to happen only in the last month of each quarter, then you just select April, July, October, and January here, and set up whatever day, week, time slot you want. And whenever we schedule the maintenance for you, we will try to honor this preference that you already selected. So as I said, this is the first part of the maintenance experience where you give us your scheduling preference. And then the second part is basically we setting up the schedule itself. And that is something we'll talk in the later session. So lead time over here is how early do you want the notifications to be sent to you. So for example, if we set up the maintenance runs for you by the end of this month, you can say, hey, start sending me notification 2 weeks in advance so that I'm ready for it. Or you could also select up to 4 weeks, 2, 3, or 4 weeks, right? Okay. So this is as far as creating the Exadata infrastructure goes. Let's have a look at creating the autonomous Exadata VM cluster. So you create the autonomous VM Exadata VM cluster inside your Exadata infrastructure. So again, this is a task that is performed by your fleet admin. So creating this is again very simple. It's just a single page, and you need to provide minimal information to create this. So you choose a compartment, and the compartment can be a different compartment from your Exadata infrastructure itself. And again, you provide a friendly name to your resource, select the Exadata infrastructure. Okay, and then you jump into the network configuration. So this is where you decide the access model for your autonomous database in this VM cluster. So in short, when you configure this, you decide whether your database needs to be accessible over the internet or not, or make it privately available within your VCN. So So this autonomous VM cluster gets deployed into your own private network, which we call virtual cloud network, of course. So you get to decide whether you put this in a public subnet or a private subnet, and also have a lot of security rules associated with it. You could also associate a network security group to this. So all the network configuration for this resource for your database happens in this section. And lastly, you also choose the license type for your autonomous databases here. So all the databases created inside this VM cluster will honor this license mode. So you have an option to bring your own license, or you could just select license included, where you'll subscribe to new Oracle database licenses in the cloud. BYOL will help you reduce a lot of costs if you already have a license on-prem. So yeah, so that's an advantage where if you have BYOL, you can bring it to autonomous database. All right, let's go to the next section. Oh, hold on. All right. Yeah, let's go to the next section, which is creating the autonomous container databases. So the autonomous container databases are created inside your autonomous VM cluster. Similarly, there's a hierarchy here. So you can create multiple autonomous container databases inside your VM clusters. All right. So creating this is again very simple. It's one single page, similar to all the previous resources. You select a compartment. It can be any compartment other than your previous resources. Select a name. And then, of course, you have to select the Exadata infrastructure and your VM cluster within which the container database needs to be created. So all the container databases are highly available. And optionally, you can also configure autonomous database for this container database. So we'll talk more about autonomous data guard in the later section of this session. And similar to the Exadata infrastructure, you can also set up the scheduling preference for the maintenance of your autonomous container database. The scheduling section looks exactly same as how we saw in the Exadata infrastructure. It's a very similar experience, right? All right. So in the next section over here, we have something related to backup retention policy. But before we talk about that, let's talk about the backups itself. So the backups are completely managed by the Autonomous Database Service. So the backups go to the object storage in public cloud. We take automatic backups for you. We take full backups once in a week, and then daily incremental, so that the database backups are always available. And you can also take manual backups as per your need. So since this is fully managed, I know Chris spoke about this. Customers do not have to worry about managing backups, taking backups, anything per se, because this is completely managed by the service, right? And in line with the backups, you have an option to set up backup retention from 7 days to 60 days. So you have different options here that you can select for your backup retention. All right. So the slight difference between, of course, public cloud and Exadata clouded customer here is that in the Exadata clouded customers, you have additional options where you could take your backup. You could sell, other than object storage, OCI object storage, you can select NFS, a network file system, and also recovery appliance. And based on the option you select, your backup retention time will vary. It can go even beyond 60 days. That's available with object storage. Let's go to the next screen. All right. So this is the next option that you have to select while creating the container databases. So this is about encryption type. So all the autonomous databases and the container databases are fully encrypted with transparent data encryption. So by default, you always by default the encrypted Oracle managed keys is what is selected. So there is no option to select something else like no encryption. So Fleet admin is the one who makes this decision for you. So you have to pay attention that while creating the autonomous container database, you have to upfront select your encryption mechanism. So this is not something an end user or a developer selects. This is your fleet admin decision, right? All right. Before we look at how to configure HSM-based encryption for autonomous database, let's take a look at how this encryption mechanism works. Let me go to the next slide and come back to this one. All right. So many customers have compliance requirements to store keys off the host. To meet that requirement, we provide full-fledged integration with the OCI Vault service. So the OCI Vault service is a FIPS 140 security level 3 compliant service. You can create an HSM-based encryption key in your vault and use that to encrypt your database. So the key that you create in your vault is basically your master encryption key, and that encryption key will be used to encrypt your Oracle database. So in a scenario where you have your key has been compromised for some reason, then with a single click of a button, you can disable or even delete your master encryption key in the vault, and the database will be automatically, your autonomous database will be automatically locked. Because we have a heartbeat mechanism that checks the status of your encryption key at a set frequency. So as you see, key management is extremely transparent to all the users here. So you have the option to enable, disable, or even rotate keys on a periodic basis. Right. So let me go back to the previous slide. All right. So in the public cloud, we have integration with OCI Vault service. And Chris did mention this earlier. In the Exadata clouded customer space, we have integration with Oracle Key Vault, which can be deployed on premises. You can create master encryption keys in both these vaults, and you make that your master encryption key for your database. On the screen itself, it's a very simple process. You select your vault and then select the key within this vault. So OCI Vault service provides you option to select hardware or a software and software-based keys. We support both, and we also support 256-bit encryption keys, which is the highest encryption mechanism. All right. And also, once the databases are created, the rotating the keys itself is as simple as a click of single button. All right, let me go to the next section. All right, just a second. Yeah, now we are in the create autonomous database section. So the one that you've all been waiting for. So again, creating this database is very simple. You provide minimal information, select the compartment, select the friendly name, and the database name is the unique database name for your autonomous database. So you have different workload options here. So shared infrastructure supports all four, which is data warehouse, transaction processing, JSON, and Apex. Dedicated infrastructure supports data warehouse and transaction processing. In this section, we will look at how to create an autonomous database on dedicated infrastructure. So that's what will come in the next screen. So and you also have an option to create an always free database in your home region, and that is applicable only to shared infrastructure. Okay. And by the way, this is the entry point for your developers and your end users. So, all right, yeah. Okay, so yeah, so let's have a look at the let's have a look at creating autonomous database on dedicated infrastructure. So you select your autonomous container database in which you want this database to be created. So you have an option to select a standalone container database or an autonomous data guard enabled container database over here. Right. And as far as the resource allocation itself goes, you input only the OCPU and the storage that is needed for your database. Storage can be as low as 0.1 OCPU to whatever is available, to the maximum available value on your Exadata infrastructure or in your VM cluster. And similarly, storage can also be as small as 32 GB and can increment with 1 GB values and go all the way up to whatever is available on your Exadata infrastructure. So an important point about OCPU is that we support fractional OCPU. OCPUs, as you saw, we support 0.1 all the way up to 0.9 as well. And this is extremely useful when customers do not want whole OCPUs or a lot of OCPUs for their databases. And this is normally the case with non-production loads or like dev and test instances where there is not a lot of use for CPUs. So this allows database consolidation to a massive extent for a lot of customers. So you could end up having hundreds of databases, hundreds of autonomous databases on a single Exadata infrastructure. So that's one added advantage by going to the on dedicated infrastructure, of course. And this is again available on Exadata clouded customer as well. And storage, again, as I said, it's in the increments of 1 GB. You could allocate as small as 32 GB or any smaller value that your database needs, right? And Chris did already demo and talk in depth about auto scaling, so I won't talk much about this one. But yeah, this is where you configure your auto scaling, and you can also change this, disable or enable this after the database itself is created. And last but not the least, you input the password for the admin user, and this is the user that will be using initially to log into your database. Okay, let me go to the next section. All right, so yeah, in this section, all right, after you input your database, there is something other than on top of the network configurations you did on the VM cluster, you can also restrict access to the autonomous database by using database level access control. So in this section, you cannot add all the IPs from which you want the database to be accessible. You can also add CIDR blocks to this level access, wherein all the IPs within that range will be able to access your database, right? So again, about the encryption mechanism, we did talk about this when we saw container database creation. So the encryption mechanism or encryption type itself is decided when you create the container database, and the autonomous databases just inherit the mechanism that is already set at the container database level. So here in the screen, what you're seeing is that the container database is using the Oracle managed key. So the same mechanism will be used by this autonomous database as well. However, once the database is created, you do have the option to rotate keys, whether it's Oracle managed key or your own customer managed key. You could still rotate it, but a single click of button. So all right, let me go to the next section. Okay. Hold on, I'm having a minor. Okay. Let's talk about the maintenance of your autonomous database dedicated resources. So we have a single consolidated view for all your maintenance needs. So as you can see here on the right section, so this basically shows you all your autonomous database resources in a single view. And you can also check what are the maintenance that are scheduled on each of these resources, information about the schedule itself, like for example, what is the patch about, and then you can see the time and everything about all these resources. And you can also change the resources and then look at the schedule for those as well. For example, your cloud Exadata infrastructure could have multiple container databases, so you could select different container databases and look at their schedule, right? So Chris mentioned this again. So all the autonomous maintenance events are done in a rolling manner, so reducing the impact on your applications. So unless otherwise mentioned, all the maintenance events are done in a rolling manner. And after a maintenance is complete, the maintenance is listed in your maintenance history section. So all the maintenance that has happened on your resources will be visible at all time in the history. Okay, let me look at this. All right. So once a maintenance is scheduled, as I said earlier, the first part is you provide us your preference. The second part is us scheduling a maintenance run based on your preference. So here in the screen, you're seeing a maintenance run that is actually scheduled. It says that this maintenance will start on December 10th, Friday at so and so time. Right. So you have an option. Once the maintenance run is scheduled, you have an option to reschedule this. You could bring it back or even move it forward. And that's why you have this edit option in front of this. You could just click on this, it will open a calendar and you can select the time, date, and you can just move it as needed. The second option is patch now. So if you click on this, as it says, it just patches your cloud Exadata infrastructure right now. It starts immediately, as long as there's no issue with your, of course, Exadata infrastructure, right? So in this release, at least in the initial release, the VM clusters do not have their own maintenance. So they always inherit the maintenance scheduling and maintenance run from Exadata infrastructure. So the VM cluster also gets patched in the same schedule. But in the future, this will change. The VM cluster will also have its own schedule that will be visible here. Autonomous container databases already have their own separate scheduling preference, and also they will have a separate maintenance run. We already saw this while creating the container databases. So over here, I haven't shown a container database, but if there was a container database with a schedule, that will also be visible here on the screen. So container database maintenance also has same options that you see for Cloud Exadata infrastructure. Along with that, they also have an option to skip patching. You can skip up to 1 quarter for autonomous container database patching. All right, is there anything else that I want to highlight here? Nope, that covers everything. So let me go to the next slide. So this is about monitoring. So how do you monitor your autonomous databases? So autonomous databases has integration with OCI monitoring service, where we emit over 40 different important database metrics. So what you're seeing here on the screen are the top 6 metrics that are visible when you go to your autonomous database page. So as soon as you open the page, this is what is visible for you. As soon as you scroll down, you see like important metrics like CPU and storage utilization. You also see like running and queued statements, etc. Right, so you have an option to select different timeline and view the status of your database at that time. We store metrics for up to 90 days in the past, so you could select any time slot within those 90 days, and the graphs will auto-populate for you. Right, and these metrics are available free of cost. So we publish these metrics to OCI monitoring service every few minutes, and it's visible for you guys. So as I said, we publish a lot of other metrics, and if you want to look at those metrics, you need to go to the OCI monitoring service, and as soon as you go there, you'll be able to see all the dedicated and shared related metrics, DB metrics. All right, then we go to the next screen. So another important point here for the metrics is that oh yes, we do send the metrics. What else can you do on top of it? Of course, you can create alarms on it. So you can create alarms on the critical database metrics for you guys and take action if a certain threshold is breached. So in this screen, you're seeing an alarm for CPU time. So I don't have the full screenshot here as it was pretty long, but the point is I could create an alarm. Say if the CPU crosses over say 70% and stays there for 5 minutes, then I want an alarm to be triggered. And the action for this alarm would be sending an email notification. So I can create a topic, which is an OCI topic, subscribe to that topic with my email ID. And whenever this alarm is triggered, an automatic email is generated and sent to my email ID. And based on that, I can take the necessary action. Right. Okay, let me move on to the next section. All right, so we did talk about this in the past in the previous section. So all the autonomous container databases are by default enabled with RAC real application clusters. So all the standalone instance of autonomous container databases are highly available. So even if one node fails, we will open the database on the other node. So as you can see, this is an example of Exadata infrastructure with 2 nodes, and the autonomous container database is open on both the nodes. So that is normally the case. So the autonomous container databases are open across all the nodes inside your Exadata infrastructure. So even if a single node fails, we'll automatically, the container database is already open in the other node. So the autonomous databases will also be opened as needed. And we reserve resources to make sure that your database has at least 50% compute power in case of a node failure, right? So moving on to the next section, that is about how are the databases open. So if you create an autonomous database with less than 17 CPUs, then it is normally created on a single node. If it's more than 17 and less than 32, then it is actually distributed across 2 different nodes. As I said, it is up to nodes. It's all dependent on how the nodes are utilized. And similarly, if it's 33 to 48, then we try to distribute across 3 nodes, but it is dependent on whether your Exadata infrastructure even has 3 nodes. So so this is the logic that we use to open autonomous databases on different nodes. And we reserve capacity as needed to make sure that in case of node failures, your database has at least 50% compute power to run. All right. So let me see if you have anything else. All right. So Now I'll hand over the control to Simon so that he can talk more about the Autonomous Data Guard, which is our DR solution, and also talk about all the database migration options. All right, so let me stop staring. Simon, all yours.
Yeah, thanks, Ranga. Let me share my screen. Okay, can you guys, can you see my screen, Ranga?
Yes.
Okay, good evening, everyone. My name is Simon. I work with Chris and Ranga. I'm a product manager for Autonomous Database. So today I'm going to cover three topics, three distinct topics. Chris and Ranga gave an introduction about Autonomous Database, and Ranga walked through the whole provisioning flow and all the resources on the Autonomous Database. I'm going to talk about the Data Guard, Autonomous Data Guard for DR. And I'm going to talk about how you can enable automatic indexing with ADB. And then the last topic of the day, I'll cover how do you move from non-autonomous database to autonomous database. So just continue from what Ranga was explaining earlier. Every autonomous database has a rack configuration. So it always runs on multiple nodes, right? In this example, I have a quarter rack. There's 2 Exadata nodes in each rack. So as you can see, you see the database are always running in a rack configuration. And what does that buy you? That provides HA, right? It gives you high availability in case one of the nodes for some reason is not available. Your database will be open and it's always up and running on the other node. It also helps us to facilitate patching where we have to work on one node at a time and the database will always be available to your applications. But what rack doesn't protect you from is in case of a data center failure, electric outage, or if there's some hardware failure on the Exadata box. Right. So this is where we talked about Data Guard, which is active Data Guard for DR. So it helps to protect site and server outages. In this example, you see I have OCI region 1. Depending on the regions that you are running on, certain regions, OCI stands for Oracle Cloud Infrastructure, certain regions do have multiple data centers, and we call those availability domains. So you see in my diagram here, OCI region 1, I have AD1 and AD3, and the DR is configured at the container database level. On the dedicated, you get to create multiple container databases. So the first one, you could say, I'm running some test databases. I put it in a HA-enabled CDB. So it's just running rack. I don't need DR support because it's just a test environment. Whereas I do have some critical applications, I need to have protection. I want to enable DR. And this first example is a local DR standby because it's all within that one region, but you have autonomous databases running on 2 Exadata rack, and they are located in 2 different data centers within the same region. And the technologies for autonomous data guard, as the name implies, it uses active data guard. Oracle the active data guard, which means the standby is always available for read, right? So it's a hot standby, and you have the options to configure whether to use synchronous or asynchronous replication. With synchronous replication, you have 0 data loss, and the RTO for both synchronous and non-synchronous will be near 0, right? It depends whether your DR is local or is it a remote in another region. So that will be timing will be between seconds and up to 2 minutes for the RTO. Now, it does support transparent application continuity. So whether you run in a rack configuration or a DR configuration, TAC, if it's configured your application, it will know which is the current live running database, and it will, even after a switchover or failover, your application will always connect to the current live primary database. Now, you can also configure a remote standby. And this is an example. I have 2 different regions. It could be Mumbai and Hyderabad. One region is the primary, the other region can act as a standby. And on that Exadata node, as you can see, Exadata Infra, you can have a hybrid mix, right? You can have some container databases, which doesn't require DR, then you don't set it up. Some can be replicating locally to another data center that's closer to your current region. And another one can completely be very different, right? You can replicate from Mumbai to, I don't know, to London if you want, right? Based on your application need. And it doesn't mean that the whole rack has to be dedicated for the primary. You can actually switch the role and then load balance across these two Exadata. Have half of them will be hosting the primary. The other half will be hosting, so primary and standby can have 50% split between the two Exadata, right? Across the two regions. You can set that up. And with Cloud Customer, so that was the public cloud deployment. With Autonomous Database also run on Cloud Customer, as Chris explained earlier. And this is almost identical, same as if you were running in the public cloud. So you have your Exadata infrastructure. If you want, you can put two Exadata Cloud Customer machines in the same data center and then set up a local DR standby. But that typically is not common. What's the most common will be the customer will have two separate data centers and they will have two separate Exadata Cloud Customer, and then they set up the DR and using the cross-region autonomous data guard to have the DR protection. And how do you enable data guard? Data guard is enabled at the container database level. So this is when you create the container database, you have a checkbox at the top. If you don't check it, by default, it will be a rack enable container database. If you check it, it will ask you, where is your container database, right? So your container database has to be on a separate infrastructure. So in this example, I have another Exadata infrastructure in Hyderabad, and I'm going to select the infrastructure name and the VM cluster where the container database will be hosted. And then the next question is then you choose whether you want to configure it using maximum availability or maximum performance. For those of you that are familiar with data guard, then you are already familiar with these, right? At maximum availability means synchronous replication. So it means that your standby is and the primary are always up to date, right? The data get committed to the standby at the same time as your primary. So make sure there's zero data loss. And then maximum performance means that there is a small chance if the primary goes down that you may lose a small amount of data, but typically that will give you the best performance because it doesn't require this standbys to be exactly up to date as a primary. So this is based on the customer's application need, right? Typically what we see is a synchronous make more sense if it's a local DR where the replication, the latency is low between the primary and the standby. For cross-region replication, we typically recommend using maximum performance. And for databases that are configured with in the rack container database, and if they need to enable DR, what you can do is you can just clone your database from the HA CDB and into the DR CDB, then that database will automatically have data guard enabled. And here's on the right, you can see this is a database that's configured with data guard enabled. It tells you the role. I'm showing you a picture of the container database currently in the standby Exadata, and it tells you that the data guard is enabled and the peer is a primary and is configured with maximum performance. So it does have the standby does have to be symmetric to the primary. What that means is that if you increase the OCPU on the primary or increase the storage on the primary, the standby will automatically synchronizes, uses the same sizing as the primary. The reason for that is that it makes sure that standby is always ready in case you need to fail over the standby and ready to take over the production workload. But the auto scaling part doesn't have to be symmetric. What that means is that if you have auto scaling enabled on both the primary and standby, remember the standby is available for read and doing reporting. If, for example, if you're doing a lot of read and writes and then the OCPU need to auto scale on the primary, Whereas on the standby, your reporting workload is quite static and you don't need more OCPU, then the auto scaling will just happen on the primary without affecting the auto scaling on the standby. And vice versa, you can do the same if you may have a lot more reporting workload on the standby versus your primary, then auto scaling will just trigger on the standby. We do offer manual switch over and failover. So you can see on the top, I circled it in red. There is a button on the standby where you can trigger failover and switch over. And this is typically also a compliance requirement. Certain customers do have to do this on a regular basis, maybe every 6 months, just to show the auditor that I can fail over to another region. My database and my application is supported. So you can do that here. And then there's also transport lag and apply lag. These are the metrics to illustrate that the data gap is running smoothly, and it shows you how far the standby is behind the primary. And you have the ability, as Ranga explained earlier, these are metrics in the OCI. So you could set up alarm and notification. So if the, say, apply lag is up to a particular threshold, then you can get alert, and then you can look at whether this is expected or not, right? It's possible it could be expected if you just did a bulk load on the primary and you running asynchronous replication. It's possible that you suddenly see a spike in lags, and that might be expected. So next I'm going to talk about automatic indexing, right? So automatic indexing, so let me explain the concept. As you know, indexes are very important for OOLTP type workloads. And typically, very commonly, is most customers, when you roll out a new application, you have your schema all fixed, you have all your data loaded at the beginning, and the performance of your database is very optimal, right? Because the DBA goes in and tune all your systems and make sure all the indexes are in place. But over time, you will see performance degradation because there's more data goes in, maybe the plans and the previous plan is no longer optimal, or you now have more objects, right? You have more schemas, more tables, and you need to create additional indexes. That's when you start to see a slowdown in the performance, and then it's always challenging for the DBAs to keep up to date because the developers keep adding more changes to the existing schema. So what ideally, all of this information is actually captured inside the database. The optimizer, the Oracle optimizer, do know these things are happening. It knows the plan that's being changed. So what auto indexing does, which is Oracle 19c features, is that it will capture all the statements that's running, and then it will look at the execution time, and then it will look at behind the scene, it will create what we call candidate indexes. So these are indexes that are not visible yet to the application, but behind the scene, it will try to look at the plan and then create some indexes and see whether that will help to improve the performance, right? And then if it does, then it will look at, depending on how you turn on auto indexing, whether it will get implemented straight away, or it will generate a report to let the DBA know these are potential new indexes that can help to improve the performance of your database. Right? If any new plan, if the indexes, these candidates actually hurts the plan of other SQLs, then it won't be implemented. It will get removed, and then the original plan will be restored, and the original indexes won't be touched, right? So these are continuous process that in the background, the optimizer can monitor your workload and then suggest additional indexes that can be created. And not just suggest, it can actually implement them and add them into your database. And it's very important for indexes, for the optimizer to evaluate the performance. The statistics needs to be updated regularly. And this is done in Autonomous Database. So optimizer stats are updated in real time. So now I'm going to show you a demo to see how auto indexing work in Autonomous Database. So I'm just going to set the scene of the database. What I'm going to do is the same swing bench applications that Chris demoed earlier. I'm going to create an autonomous database. Then I'm going to create the swing bench schema and load the data into the database, but without creating all the indexes. Out of the box, I believe there are like 16 indexes that come with the order entry schema as part of the swing bench. I'm not going to create any indexes, and then I will turn on auto indexing and let the optimizer start evaluating the current workload. So one thing to know, for auto indexing to work, you have to enable it, and at the same time, just run your regular workload. So the optimizer can look at the activities and then provide suggestions on what additional indexes will be able to help with the performance. So here I have created a database, autonomous transaction processing database called Swing DB5, as you can see here. And then what I'm going to do, I already have Swing Bench installed on a compute VM on OCI. Now I'm just going to download the wallet to Swing Bench DB5 database. And I'm going to configure that and just uploading that to the VM now, and then setting up the connectivity to make sure my Swing Bench application can connect to this database. And then I'm going to call the script, which will populate the schema, load the tables, but without creating the indexes. So I'm just setting up the connectivity. So out of the box, you can connect to the autonomous database using a wallet, using TLS connections. On dedicated, you also have the option of just using a regular TCP connections. So wallet can be optional on dedicated. Here is the script. It's a Swing Bench script. It just connects to the Swing Bench database and without creating any indexes. And now I'm just going to kick the job off. So you see it's using a JDBC connection to connect to Swing DB5. And now it's gone in and created those tables and inserted the data. As you can see, as a validation step, it tells me all the objects has been created, tables, and nothing is invalid, but what's missing are indexes, right? So all these 26 objects, these 26 indexes hasn't been created, and 13 million rows of data are in the database. So I'm just going to confirm that in SQL Developer, connected as the admin user in Swing DB5. So Swing Bench used for the order entry schema, it uses the SOE user. See, there's 0 indexes under the SOE schema. All the auto indexes configuration is actually stored in this view. So as you can see, by default, it's off. Now I'm going to enable it. You can enable it using PL SQL, just execute a package. But here I'm just going to show you how you can enable it through Enterprise Manager. Most of you are probably using Enterprise Managers today to monitor your on-prem databases. You can do that here with Autonomous. As you can see, there's a configuration, index mode, default is off. You have the options to say implement, which will create the indexes, or just put it in a report only mode. So I'm going to implement it. And then I'm going to say just create indexes for under the schema for SOE. You also have the options to say exclude certain schemas, right? So the auto indexing will just focus on the SOE schema. Now I'm going to kick off Swing Bench just to make sure there's activities, rewrite happening to the database. And now the auto task is now running. Once I set it up to implement, you see the auto index task, which is running in the background. Every 15 minutes, it's going to check the activity, and it's going to monitor the activity and start creating these candidates for review to compare the performance between the current workload, current indexes as well, between the current indexes and those that's being suggested as candidate. So when these indexes are created, they are in the SOE schema, but they all prefix with sys_AI. So they are under, so you know these are indexes that are created by auto indexing. And they're not visible. You can see that they are invisible. So they are not used by your application. It's only used by the optimizer for evaluating the performance. And then once it's gone through all the evaluation, make sure that it doesn't impact the performance of other SQLs. It will then make them visible, as you can see at the bottom. It will then turn them on and make them visible to your database. So this is a very quick demo to illustrate how auto indexing work in the Autonomous database. And then the final topic that I'm going to talk about is the migration to the Autonomous database. So one thing I do want to talk about, there's actually a lot of these questions came up at the beginning when Chris was presenting. I saw a lot of questions about how do I certify applications with Autonomous database, and then there's third-party applications. I have custom applications. So Autonomous database is slightly different to the non-Autonomous database in a sense that the Autonomous database, in terms of access, you don't get sys and system access to Autonomous database because the Autonomous database is all managed by Oracle. So it's Oracle managed cloud service, database cloud service. So you don't get access to the underlying OS. You don't get access to the container database. You only get access to connect to the Autonomous database via a user called admin, which is very similar to sys, but it doesn't have access to every single sys objects. You get access to things that we deem that are important for Autonomous database. So not all features that you use today, if you have an application on-prem that's running on, say running on 11G, 18C, you may be using some features that are no longer what we call optimal in 19C. These are what we call legacy features that they are still in the database, but they are not recommended to use. So those are not available. So ideally what you want to do is you want to go through these, do a check to make sure these objects that you're using today are supported in the Autonomous database. And some of these features are automatically migrated. So for example, if you're using basic file lobs, during the migration to Autonomous database, it will automatically get converted to a secure files lob, which is the supported feature on Autonomous. There's things like DBMS job, which is the older version, which has been replaced by DBMS scheduler. So those will get replaced. So there's certain features that will not work and they will get migrated. But then there's also some features like, for example, common users, which are container database users. As I mentioned, you do not have access to connect to the container database. So there's no concept of common users in ADB. There are certain features that are currently not enabled, maybe because of security, UTL, TCP. There's also, because each one, you get access at each ADB level. So some of these features are blocked. So it's very important for you to evaluate before you move to Autonomous database to see how many of these features are being used in your current application, and then work on a plan to migrate to Autonomous. So we do have a tool to help you. Some of you may be familiar with the Schema Advisor. This is actually the successor to Schema Advisor. It's called CPAT, which stands for Cloud Pre-Migration Advisor Tool. So what it does is actually it connects to your source database. So your source database can be on different platforms, on different versions of Oracle. and it will look at all the objects in the database, and then it will flag any potential incompatibilities in your database that may have migration issue when it get moved to the autonomous database. So here's an example of a checklist. Remember, I said that there's no sys and system access in autonomous database. So here I run the schema, I run the CPAT against my source database, and it notices certain objects that's under sys and system. And these are not system objects, right? These are objects that are, well, my verification function is definitely a function that someone created under sys, and then there's some other additional indexes or sequence that are created in the schema. So those will not be migrated in ADB. So the report actually helps you to identify incompatibility, as well help you to evaluate the migration effort, right? So the tool itself is Java-based, which means it can run on any platform. It can be a standalone tool, or it also get bundled with something called CDM, which I'm going to cover coming up in 5 minutes, which is a separate migration tool. It doesn't, so if you're concerned that whether it will create some objects in your source database, it doesn't do that. All you need to do is grant it select access. It doesn't install anything into your source database. And it uses JDBC to connect to the source database. And then during the analysis, it will generate a report in either JSON or text output, right? So, and flag all the different compatibilities issues that it discovered during the analysis. So based on that result, assume everything goes well, and then even if there's incompatibility, there may be things you may be using some older data types or some PL/SQL that are not supported, then you can just change them at the source. And then when we talk about the migration techniques, so you can't just take an existing RMAN backup for your on-prem database and move that to the autonomous database just because of some of the differences, right, between the autonomous database and the on-prem. What you do is you actually copy the data across or move the data from your source database into the autonomous database. And there's two ways to do that. You can use a direct way. Direct typically is through database link to connect from your source database to the autonomous database and move the data that way. And that way is typically fast for small data sets because you don't have to write it to a staging area for the upload. The second way is through, depending on if you're running autonomous in the cloud, then you do a staging area, export the data, put it into object storage. If it's running on cloud customer, then you export it to a local file system, right? NFS server of the customers, and put the data files or the export there. And then from there, you upload it to the autonomous database. So typically, these are the two ways of migrating your data. And there are multiple options here to move your data from the non-autonomous to autonomous. And I'm going to go through them one by one. Database action is probably the simplest because this is something that's incorporated into ADB. In fact, it's the first button on the ADB page, database action, and it has something called load data. It allows you to load local files, or if you have database links set up between the autonomous database and your source database, you can also do remote table load between them, or you can load from a cloud storage from other buckets from Oracle as well as from AWS, Azure, etc. Now, the cloud storage and local files works with CSV, basically text file, JSON, XLS, and so on. So these are typically good for smaller sizes where the text file is less than, in megabytes, right? So then it can load through HTTP from your browser, and then it trigger the load into the autonomous database. The second option is to use SQL Developer. SQL Developer, I'm sure most of you are very familiar with it. It's a desktop tool, and in SQL Developer, it does allow you to upload files either locally on your desktop or on your laptop directly into the target database, or you can set up connectivity to the object storage. If your files are already in object storage, then you can set up the connectivity to object storage and initiate the text file load into the Autonomous database. This is very simple and intuitive. If you already use a SQL Developer before for data loading, then this is one way of loading data into the Autonomous database. And then the other one is SQL Loader. SQL Loader, most of you should be familiar with. It's been there probably since day one of Oracle. It's a tool that comes with the database and allows you to load local files into the Autonomous database. And it uses basically SQLnet to connect to the database. The good thing about SQL Loader is it actually allows you to do transformation. So you can upload multiple tables at the same time, have concurrent files, and it generates logs. Any records that it rejects, you have records of those, and you can do certain transformation based on certain values, populate other columns. And so it's more sophisticated than the other two I talked about earlier. And also it has better performance just because you can do concurrent files and tables at the same time. And it works on text files, right? SQL Loader. So it's a text file based loading of data. And you can load data from non-Oracle database too, right? So if you're migrating from non-Oracle database into Autonomous, you can just extract those data into text file and use SQL Loader to load the data. Now I'm going to talk about Data Pump. Data Pump is export of the Oracle database. Now, there's a lot of advantages of using Data Pump. First of all, it's not text file, so it's more compressed. It's a binary export of the Oracle database. It allows you to, this is especially, so I would say the first three I talked about are good if the databases are relatively small, under a few gigabytes. Those are good resources to use. Anything greater than that, especially in the terabyte range, you should maybe look at using Data Pump, which is a database export. Data Pump has been available Oracle database for a long time, and it supports different versions of the Oracle database, and it's also platform independent. So you can do an export of Data Pump from Solaris, from Linux, from AIX, and then import that into the Autonomous database, right? It handles character set conversion automatically as well. So it knows your source character set of your source database. During the import, it will figure that out and will convert it to the character set of the Autonomous database. And you can choose whether you want to import all the tables or only certain schemas. And you have the option of setting up database link, so it will import the data directly without going through object storage, or you can export it to object storage and then use object storage. From object storage, use Data Pump to directly import into the Autonomous database. Now with Data Pump, the consideration is good for large amount of data, but because of in reality, this is more like an offline migration, because if it's a large database, the import of all the data could be multiple hours, right? And then if your database are 7x24, it means during the time while it's loading, your database is now out of sync with your Autonomous database. So this is like an offline migration. Now I'm going to talk about two ways of supporting online migration to the Autonomous database. So ZDM, zero downtime migration, is a tool that allows customers to move from non-Autonomous database to Autonomous database using all those things that I talked about earlier. It integrates with the CPAT advisor. So prior to the migration, it can run the CPAT for you and then flag any potential incompatibilities. And then it leverages data pump to directly export and import the data through database link or through object storage and load the data into the autonomous database. And it uses MAA best practices to support zero data loss. It actually can incorporate Golden Gate into the picture. So it captures the delta between your export and the time that you want to switch your database over. All the delta changes that's happening on your source database can be captured and can be replayed back onto the autonomous database before you switch over your application to run autonomous. So let me explain this in a bit more detail through a diagram. So here I have a active source database, right? So I have user currently using the database. The database is always up and running, so there's data going in. Now, first thing you need to do is obviously provision an autonomous database. This could be in OCI or it could be in Cloud Customer. Provision the autonomous database. Set up ZDM on a machine. It could be on the source database machine, or it could be a separate compute. Install and download and install ZDM. The requirement is that this machine needs to be able to have network connectivity to both of the source and autonomous database. It needs to have SQLnet access to the autonomous database, and it needs to be able to do SSH to the source database so it can initiate the data pump export. And then you set up Golden Gate. So Golden Gate is very easily set up if you can. There's a marketplace image in OCI, so you can provision a Golden Gate image, and then you just point ZDM to it. It will provision and set up the Golden Gate automatically, and it will point back to the source database, and it will start capturing on the source, right? It will start capturing all the changes, and then it will initiate the data pump export from the source database and then copy that to object storage if it's in the public cloud, or to a NFS if you're running a Cloud Customer. So capture all the data pump export to the staging area, and then CDM will initiate the data pump import from the staging area into the autonomous database. After that, now you have a snapshot of your autonomous database is now in sync with the export of the database at that moment in time, right? But there are still some deltas that's been captured by Golden Gate that's sitting in the source database. So ZDM can initiate the catch up, right? So all the apply that was on the target will now be copied to the autonomous database. While you are still, some of the changes, the user is still updating the source database, and Golden Gate will continuously applying this update to the autonomous database. And whenever you're ready, you can do a switch over using ZDM, and then now the data has caught up, and now your application the users can now connect to the autonomous database and run your application. So everything is integrated, that all the process, all the configurations can be done through CDM. And then the last option I'm going to cover is CDM is a command line tool. Database Migration Service is an OCI cloud service that leverages ZDM, leverages Golden Gate, leverages Data Pump. So it gives you a UI experience, how to manage these processes I talked about earlier. You can set up the source and target database as long as OCI can reach those databases. And then you can choose which schema to migrate. And then it breaks down these migration tasks I showed earlier from CDM into stages, and you can check the progress, right? You can actually resume and abort and then look at log files. On the right, you can see there are different phases of those migration. They are shown through the console, and you can actually see how long it takes at what stages of those the task, right, for the migration. So it's DMS or Database Migration Service is a cloud service that integrate with ZDM and Golden Gate and data pump and object storage allow customers to move from non-autonomous database to autonomous database. So that wraps up my slide. So that's in terms of the presentation. We cover a lot of content. Chris, Ranga, and I cover a lot of content. I think we have about 10 minutes left. Maybe we can open it up for Q&A. Or
Yes,
we can
please,
go through, yeah.
I think maybe you can pick if you see any good questions in the chat, Chris. Maybe you can just pick up and answer. Or do you see any common question?
Yeah, well, actually, we did answer a lot of questions, and thank you everybody for the questions. We got about 60 questions, so that's great. Some people, a couple of folks actually raised their hands, and so if you want to speak up, this is a good time to ask anything you might want to ask.
Yeah, go ahead and raise, because I was actually keeping them down. But yeah, please ask questions. If you want really good, yeah, make sure that you ask a really good question, not a silly question.
Well, there are no silly questions, so I think I'm fine.
Somebody just come and say, what is autonomous database?
Yeah, as long as you're not asking me how to make medu vada, then that's fine.
Guys, this is a really right opportunity. There are like 78 people in the still there. Thanks for that. But please ask, or you want to say thank you. That's also fine.
I would address in general just one thing, because I see a lot of questions in that area, is that migration. What size of databases are good candidates, all that. So folks, we have done some amazing migrations into autonomous large databases. Data pump works great. I mean, I think the fact that it does take that time it takes to export and import, but its throughput has not been an issue. And again, as Simon explained, there's this combination of using data pump and Golden Gate for applications that are 24/7, that you want to have the minimum amount of downtime possible. All that is automated in the tooling in ZDM and in the data migration service, depending upon whether you want to use it for cloud at customer or public cloud, right? So between these options, it works quite well, and we have seen some really good success migrating customers to autonomous. And if there's anything if you have a question, I just actually put my personal email, my Oracle email, in the chat. So reach out to me, reach out to Simon, Ranga, or to Sai, and we'll be happy to kind of look at your use case and kind of work with you.
I can see a lot of thanks in the chat, Chris. Definitely somebody is super excited. He says, excellent session for me as a developer. Thank you. This is what is important, right? Somebody is presenting at 5 a.m. in the morning. So at least we should say thank you as two words.
No, more than that, I'm happy that autonomous is making all of our existing customers very excited, right? These are the people that we work with for decades, our DBAs, admin friends, and we have constantly been saying that the whole autonomous journey is to make their lives easy, right? I think that is more apparent now than ever, right? That this will allow people to manage a lot more effectively while still retaining what they're doing. So there's a specific role for everybody in this, in terms of administering these large fleets of databases that you now have, but without the headache, without the annoying stuff that you never wanted to begin with. So people are finding it exciting. We are very excited that we can bring this to the table, and we are happy to work with you and your customers, right, to make you successful.
Yeah, the one question I see, Chris, yeah, this is a great innovation, but it's not really certified and compatible with many of the applications. So how do we address that particular? We know, you basically said, run the script and is it compatible or not? But how do you address to a customer? Because this is like you're showing a Tesla car without road, right?
Right. No, good question. So look, when you say certification, there are two things. There are certifications for specific apps, right? Which is an ever-growing list of things that we are on. We are starting with the Oracle applications. We are very close to certifying eBusiness Suite. We are not exactly there. We've certified PeopleSoft, JD Edwards, Siebel already. But we also know that Oracle apps or packaged apps is not the largest workload that customers run, right? I'll tell you statistically, Oracle customers run their own homegrown apps more than any other third-party apps on Autonomous, not on Autonomous, I mean on Oracle databases. So all those workloads are great candidates to move to. Yes, the certification is something you would need if you're looking at an Oracle application. So as I said, that's work in progress. And as time goes by, we'll certify more and more applications. If there's any third-party app that you think you want to get certified, get in touch with us. We'll prioritize based on what you want to get done and how many customers want it, of course. So that's that. In terms of running CPAT to determine if your applications comply or not, I'll tell you, in most cases, the limitations are around old practices. So, if you have created objects in system tablespaces, I've seen that 90% of the time that's the issue. It's like, okay, you have created objects in system, and that's what was working fine on premise. Nobody ever told you not to do that, although it's never been a good practice. We all know that. Now, in Autonomous, because you do not have access, you actually have to move it. So that aside, there is very little that I've seen that blocks you, right, from using Autonomous. I mean, at the end of the day, for the most part, it is, and the database engine is the same as what you use on premise. So we do not expect any major application changes. It's these little things that you have to kind of account for, that you have to factor in.
Is SAP certified?
No, with third-party apps, again, legacy apps have done so much and they've built so much. We have to thoroughly vet those out before, especially if Oracle has to sign off on those. So that is work in progress. As we get more and more demand from customers on specific apps, we prioritize those and we work on the certification.
Super. So any more questions, guys? We are already top of the hour. But I think I can see a lot of thanks. You should look at the chat, Chris. That's what we like. Definitely the detailed sessions and deep dive sessions. And so let me share my screen. So you have any closing comments, Chris, before I share my screen?
Just a big thank you to everybody. Look, on a Saturday night, as I said, for you to be excited to join us, listen to us, 2 hours long, I sincerely appreciate, like, all my customers, all of you, all the participants on the call.
Thanks, Chris. I think it's other way around. Like, you guys are joining in the weekends and the morning, Saturday morning. So thanks a lot for especially, Ranga first time and Simon, joining to AIOG because Chris is anyway part of AIOG. So thanks a lot for, joining and supporting us, and definitely we'll be hosting more autonomous database because we are moving towards autonomous database now. So I'm sure everybody's in that starting journey, and we'll definitely face a lot of hurdles, and we need your support because we can't find this information online. So we need to have something like these type of sessions where we can actually share questions and answers, right? So thanks a lot for your time. So tomorrow is actually again a special day. So please join. Sunday is again, there's nothing to learn much because that's why it's a very lightweight sessions. Tomorrow morning we have Ask Sam Anything. Means basically it's you know these guys are like you can ask anything on maximum availability architecture, rack, high availability, all the stuff. Okay, so that is the ask anything means. Okay, and also we have 2 labs, really good labs. So we picked from list of 50 labs, we picked actually 4 labs. So make sure that you join these labs, and really interesting HOL labs. And also we have a meet, greet, and chat with Oracle Aces of India, and you will be like introduced this Oracle Ace program and the benefits, etc., etc. Right. So with that, again, guys, not only thanking them here, you can also thank them in the Twitter, right? So that will be and then the whole global community will look at why these guys are thanking Chris. So that way people get more advantage, and people actually leverage the product teams, and they provide a lot of feedback. An important thing, right? So let me close this one. So please provide your feedback directly to Chris and team, right? So these are the challenges when we go to customer. These are the challenges. Like how do we tackle? How do we success in that story? Please share with them, right? So definitely they'll get definitely you'll get some help. So with that, thank you so much, Chris and team. Have a nice day. The rest of the guys, good night. I'll see you tomorrow morning at 9 o'clock. Bye for now.
Thank you,
Thank
everybody.
you all. Thank you.
Thank you.
Bye.